Good morning, teachers and my dear friends. I am Pratham Mehta and I am studying in Science Anchor Kachi Engineering College. So, today I am going to demonstrate about SHM. What do you mean by SHM? SHM is a simple harmonic motion. It is a special kind of oscillatory motion or a periodic motion where the restoring force is directly proportional to displacement and the direction of the displacement is in opposite direction to that of restoring force. It is a sinusoidal in time. Now guys, consider an example in which the string is attached to a bob, wherein the bob is an eraser over here and this is a string. Now this bob is at the initial position or the mean position. If you displace this bob like this for 10 oscillation, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. In this, when the bob moves towards this side, it reaches an extreme position and the bob tries to reach to the mean position, wherein the restoring force F acts in the opposite direction and the displacement is towards the right, which is in opposite direction. Therefore, we say the formula as F bar is equals to minus Kx bar, wherein the K is the force per unit displacement. It is a constant for taking out the proportionality sign. So now guys, we have developed the basics so we can start with our derivation. So today I am going to talk about differential equation for linear SHM. So as I have discussed earlier that restoring force is directly proportional to displacement. Over here F is the restoring force and X is the displacement. So we can say that F bar is equals to minus Kx bar to remove the proportionality sign, and it minus indicates that the direction of the restoring force and the displacement are in the opposite direction. So we can say, we know that velocity is the derivative of displacement with respect to time and acceleration is a double derivative of displacement with respect to time. So we also know that force is equals to mass into acceleration. That is Newton's second law. Therefore, from 2 that I have defined over here, we can say that force is equals to mass into d square x bar upon dt square, which is acceleration. A is equals to d square x bar upon dt square. Therefore, from 2 and 1, we can say that m d square x bar upon dt square is equals to minus kx bar. Taking minus kx bar on the left hand side, we get m dx square bar upon dt square plus kx bar is equals to 0. Now let's divide mass. So it will be d square x bar upon dt square plus k by m x bar is equals to 0. Now guys, you might have noticed that I have kept k by m separately in a bracket because k by m is a constant which is known as angular velocity. So for SHM, when we oscillate the bob, the angular velocity has been measured and not the velocity. So this is the differential equation for linear SHM. So now guys, let's go for derivation of acceleration, velocity and displacement that takes place in the oscillatory motion. Therefore, as I have stated earlier, k by m is equals to omega square, which is a constant. Therefore, d square, let's consider, before that let me tell you, let's consider the magnitude of this equation. Therefore, d square x upon dt square plus omega square x is equals to 0 as derived from the equation 3. That is the differential equation. Therefore, we also know that acceleration is d square x upon dt square Therefore, we can say that d square x upon dt square is a plus omega square x is equals to 0. Taking omega square x on the right hand side, acceleration is equals to minus omega square x. And this is the equation for acceleration in a linear SHM. It defines that when acceleration goes towards the right, it acts towards the right. So displacement acts towards the left. So that is why there is a negative sign over here. So we also know that acceleration is the derivative of velocity with respect to time. Velocity is also defined as derivative of displacement with respect to time, as stated earlier. So acceleration is equals to d square x upon dt square is equals to dv upon dx into dx upon dt, and we know that dx upon dt is nothing but velocity. So we can say that acceleration is equals to v dv by dx. So from 4 and 5 we can say that v dv by dx is equals to minus omega square x, which we have equated with the acceleration. Therefore, they are multiplying dx on both the sides. We get v dv is equals to minus omega x dx. Now we will integrate the given equation. So integral of v dv is equals to minus omega square outside the integral, because it is the constant as stated earlier, into integral of x dx. So therefore, after integrating it, we get v square by 2 is equals to minus omega square x square by 2 plus c, where c is the constant. This constant, to find out this constant, we have to assume the boundary condition in which the bob goes to the extreme position, and at that point the velocity becomes 0 and the displacement, that is x, takes the value of maximum amplitude, that is a. Therefore 0 is equals to minus omega square a square by 2 plus c. How did I get this? Velocity is equals to 0, I substituted over here, and x is equals to amplitude, that is a square. Therefore, taking minus omega square a square on the LHS, we get c is equals to omega square a square by 2. Now resubstituting the value of c into original equation, that is v square by 2 is equals to minus omega square x square by 2 plus c. Therefore we get v square by 2 is equals to minus omega square x square by 2 plus omega square a square by 2. Therefore we get v square is equals to omega square a square minus x square, taking square root on both the side, we get velocity is equals to plus or minus omega root of a square minus x square. This is the expression for the velocity of the oscillatory pathway. Therefore, from velocity, we know that dx upon dt is v. So dx upon dt is equals to omega root of a square minus x square. Over here, we are taking omega as a positive value. Therefore, bringing root of a square minus x square with dx and dt over there. Since omega is constant, it will be multiplied with dt. So taking an integral on both the sides, we get integral of dx upon root of a square is equal to omega integral of dt. There is a formula for integral of dx upon root of a square minus x square. Therefore it is sine inverse of x by a is equals to, omega is a constant, so it remains outside, omega and integral of dt is t plus a constant, that is alpha. Alpha is nothing but it is an epoch, which is also known as initial phase of oscillation. Therefore, taking taking sign on RHS, we get x by a is equals to sine omega t plus alpha. Multiplying a on both the sides, we get x is equals to a sine omega t plus alpha. Now, this is the expression of displacement in linear SHM or for the oscillatory pathway. So, at the end, we conclude that we with three equations, that is acceleration is equals to minus omega square x, velocity is equals to plus or minus omega root of a square minus x square, and finally x is equals to a sine omega t plus alpha. Thank you.